In this video, I'm going to solve the quiz questions that was in the quiz 6. You may have different questions than I do because it is randomly generated in the system. But it should be the same way. The solution methodology should be the same way. So the first question is the optimal review interval for a product is 211 days. What is the equivalent review interval in month time unit? So how frequently you review your inventories if it is in months, right? So the calculation is very simple. 211 and 1 month is 30 days. So I'm going to just divide it and say t is equal to, it asks me like 3 decimal point accuracy. It is 7.033. Right? So that is the answer for that first question. The second question says a distributor has 3 warehouses storing a product that has an average demand of 255, 490 and 455 per month. If the distributor decides to serve all customers from a single warehouse by consolidation, the average demand at this single warehouse would be what? So if you remember, during the inventory consolidation, the new demand is basically demand 1 plus demand 2 plus demand n. So that's basically what it is. So it is asking me the demand, and that is 255 plus 490 plus 455. So the demand is, the new demand would be 1200. All right. Again, this is the solution the quiz system generated for me. The question generated for me. Your numbers, the monthly demands would be different, and your final result will be different too. The third question: the standard deviation of demand for the above product at these warehouses are 62, 20, and 37 per month. Again, if the distributor decided serving all customers from a single consolidated warehouse, the standard deviation of demand per month at this single warehouse would be the same logic this time. As you know, we cannot add the standard deviation, but we can add the variances. So I'm gonna calculate the variance of these months or warehouses, and then get the square root of that one to calculate the final standard deviation. 62 square plus 20 square plus 37 square, and then the square root of that number. It says put it in 1 decimal accuracy, and that is sigma is equal to 74.9 in my case. Next question. A distributor wants to see the impact of risk pooling on various inventory management parameters. The distributor currently has 4 warehouses, each facing normally distributed, independent and identical demand for a product. Each of 4 warehouses currently keeps 336 units of safety stock, which is calculated based on continuous review policy. What would be the new safety stock if the warehouses are consolidated into a single warehouse? Assume the same customer service level before and after the consolidation. So before the consolidation, I have z sigma square root of lead time, that is safety stock, and this number is equal to basically 336. After the consolidation, I'm asked the safety stock number. Now, I'm already told that Z is the same, right? And I don't have any information regarding LT, but there is no indication that LT has changed. So the only change is the sigma before and after consolidation. So the sigma is going to be basically sigma square root of n. This is, remember, if we have identical warehouses, that's what you could do. And sigma in this case, sigma is equal to basically sigma 1 times square root of 4, and here I get the sigma equal to 2, basically sigma 1. So if I go back and add the index here, sigma 1 square root of lead time, basically what it is saying is this needs calculation is z times 2 sigma, that is my sigma 1 square root of lead time. That means I'm gonna just multiply by the 2, right? 2 times 336. So, and that turns out to be 672 units. All right, next question is, the optimal review interval for a product is 3.523 months. What is the equivalent review interval in weeks? Again, this time we are going from a bigger time unit to a smaller. That means we are going to multiply 3.523 times basically 1 to week, and 1 month is 4 weeks. So I'm going to multiply by 4, and the result is 14092. Right. And finally, I have this question. A distributor wants to see the impact of risk pooling on various inventory management parameters. The distributor currently has 8 warehouses, each facing normally distributed, independent, and identical demand for a product. Each of 8 warehouses currently orders 395 units of products together whenever an order is placed based on a continuous review policy. What would be the new order quantity if the demand at 8 warehouses consolidated into a single one? This is basically again very similar to this calculation for 4, where I was asked to do the standard deviation, right, as an idea. So what I know is that Q star, that is 2AD1 for one of the warehouses, IC square root of that number is 395 before consolidation. Right. And after the consolidation, I'm going to use the same formula, but I need to know what is the new demand for basically consolidated warehouse. So that is N times D1 or DI. Basically, I'm going to say the demand at the first, second, third, and 8 warehouse, add them up, right? So this is the new demand after the consolidation. So Q is equal to 2A 8D1 square root of IC, right? And that is, if I do the math, it is basically 2AD1 IC times square root of 8, right? So I just separated, so I need to multiply by 8, a square root of 8 basically. In that case, my Q is 395 times square root of 8, and that turns out to be 1117.